Greetings, class. Today I'm going to be leading you through the teacher presentation on line following logic. So just to make things clear, you guys are going to be working on Cyber Robotics 102 all the way down line following logic. And so I already went through these in class and gave you a good pointer on how to accomplish this one. So today what I'm going to do in this video is I'm just going to go through this presentation, which will help us to gain an understanding about what we're actually doing during this line following exercise. So here we go. All right. So we didn't go through the last time, so I'm just going to skip that slide. Okay, what have we got today? Line following, two-state control, three-state control, and proportional control. Up until now, we've been using either the gyro sensor or the turn 2 block for performing turns. The drive distance block allows Ruby to drive precise distances, but only straight forwards or backwards. We use Ruby sensors to navigate missions based on data she collects along the way, marking coordinates or setting variables. But let's think about smooth turns. They're quite hard to execute precisely with just normal blocks, even if we know the exact shape ahead of time. Okay, so this is a whole lot of information, but basically it's saying there's a different way to turn. To help Ruby through a smooth turn, we'll use routes drawn on the floor. So if I want to turn around these blocks, well, I could just code this in a certain way, but if there's a path already, I want to be able to follow the path, and that's what line following logic is all about. So how are we going to follow these lines? That's the question. All right, so in this lesson, we will have Ruby follow the routes drawn on the floor with one of her color sensors, which are pointed down at the floor. So our color sensors are right here and right here. So these are Ruby's color sensors pointed down at the floor. Following a line is not always an easy task, even a straight line. The catch is if we're not driving exactly straight forwards, we'll have to adjust course a little to the side in order to get back on track. So if we go off, we're going to have to adjust. After adjusting a little to one side, we're off track again, and we have to adjust to the other side. Now we're off track yet again to the other side, and we have to adjust course again. So as you see, it's kind of going back and forth and back and forth. The result is a slightly zigzaggy advance forwards. It's called two-state control, also called on-off control. Why is it two-state? Well, either you're going to the right or you're going to the left. So those are the states, either you're going right or left. It means that Ruby will only drive in two directions. Slightly to the left or slightly to the right. Exactly what I just said. Cool. Did I just skip a slide? Oh, no, I didn't. I want to make sure I didn't skip one. Okay, Ruby is using her color sensors to follow the lines. If the floor is brown and the line is green, then Ruby is working with these two colors, right? The thing is, once Ruby has left the green line, she can't know if she's on the brown ground to the left of the green line or on the brown ground to the right of the line, right? So if Ruby is sensing brown, Ruby doesn't know if it's to the left or to the right. So that's a problem, right? Because we can't just say, if you sense brown, then go to the left, because what if Ruby's over here? For this reason, we'll use one of Ruby's side color sensors, say the left one, and focus on the left edge of the green line. Now this is one way to do it. There's other ways to do this, but this is the way that they're talking about here. The moment Ruby leaves the edge of the green line, our sensor no longer detects the green. We'll program her to adjust course and correct herself by driving just slightly the other way. So the moment that this sensor is no longer sensing green, it's like, okay, well, I know I'm immediately to the left. So I got to adjust and drive the other way. Here's how it works. Inside a repeat forever loop, we'll place an if-else loop. The condition is Ruby's color sensor detecting green, the color of the line on the floor. So if the left color sensor get color name equals green, so get the color name that's being sensed. The name of the color is green that's being sensed. If the left sensor is sensing the color green, do this. Set wheel speed what? And these numbers are wrong. At first, we'll program Ruby to drive slightly to the left to put her on the edge of the left of the line. Um, so I don't know if it's going to change it, but so if you sense the color, do this, and if you're not sensing green, do this. That's what the else is going to say. Okay, so here we go. In order to drive slightly to the left, Ruby's wheels need slightly different values. So if the sensor is sensing green, what I want to do is go slightly to the left. And in order to go slightly to the left, I'll do left 20 and right 30. The left wheel has to spin at a lower setting while the right wheel spins at a slightly higher setting. That makes it turn left. Now she's past the edge of the line and no longer sees green. So if Ruby's sensor was on the green line, the left sensor was on the green line, that's great. Let's make it turn left. Well, at a certain point, it's no longer going to be on the green line. Let's use this green line. Ruby's no longer going to be on the green line. The sensor's no longer sensing green. So what do I want to do? I want to turn right. So the left wheel has to spin at a higher setting to turn right than the right wheel, while the right wheel spins at a slightly lower setting. Perfect. So if it senses green, turn left by causing the right wheel to turn faster, or else turn right by causing the left wheel to turn faster than the right wheel. So if it senses green, turn left. If it doesn't sense green, turn right. So what's going to happen is while it's on this green line, it's going to, I'm on the green, turn left. Oh, I'm no longer the green, turn right. Oh, I'm on the green, turn left. I'm no longer on the green, turn right. And it's going to keep going back and forth, which is exactly what I want it to do. Going green mission. This is what the slight zigzag forward motion should look like. And so I demonstrated this in class. Take note of the left color sensor's reading. Okay. Every time Ruby leaves the green line and the sensor no longer senses green, she changes direction. So look, the left color sensor is alternating between green and brown. And every time it alternates between green and brown, it changes direction. So if it's sensing green, it wants to turn to the left. If it senses brown, it turns to the right. So there you go. That's the first mission, going green. And then the green again mission, it's the same deal, except you have to go faster. But be careful, because when Ruby's driving faster, Ruby might lose the edge of the line. So you have to be careful not to go too fast. When driving quickly, Ruby covers more ground. The zigzag is bigger. Right? So by the time Ruby reacts, the robot's actually gone farther off the line. Because of this, Ruby might lose the left edge of the line, especially if she's relying on her left color sensor trying to follow a line which is curving to the left. So, right, she might overcorrect, and then by the time she loses that edge, she'll cross the green line into the brown floor on the right of the line. Well, now she's on the right of the line. Now her sensor's sensing brown, which is making her going to turn right because it's sensing brown. Remember, she wants to turn right when it senses brown. But if she's on the right side of the line, she's going to keep turning right, and that's not going to do her any good. So that's a bad situation right there if you cross over the line with this programming. Ruby's program says to drive slightly to the right if she doesn't see green, so Ruby goes right. Exactly what I just said. So that's a problem. It's important to choose which edge of the line we want Ruby to track, and according to that, which of Ruby's color sensors we want to use to track the line. So if we're tracking the left edge, we're going to use the left color sensor, obviously. Since our route curves left, it will be easier to follow the right edge of the line using Ruby's right color sensor. We still might not stay on the line's edge 100% of the time, but at least we'll be curving left. So boom, curving left, follow the right edge. If we're going to the left, it's easier to follow the right edge because it's going to be a whole lot less likely that we overcorrect. This means we also have to switch the do-else statements around so our first time driving is slightly to the right. So if we're using our right color sensor sensing green, then if the right color sensor senses green, well, then we want it to go to the right. Okay, we want it to go to the right. And how do we do that? We make the left drive faster. And if it senses brown, we want it to go to the left. So it has to switch it around, and you got to think about that. If I'm tracking this edge, if I'm on green, I want to go to the right. If I'm on brown, I want to go to the left. So it's opposite what it was before. Here, if I was tracking this edge, if I'm sensing green, I want to go to the left. And if I'm sensing brown, I want to go to the right. So the opposite is true, depending upon which edge you're tracking. Okay, look at this cool question mark route RubyS Drive. Isn't it cool? But now we have a problem. The route is colored with two different colors. How will Ruby cope? Do you remember how to deal with a line that is first green and then changes to yellow? Click me if you need a reminder. Sure, I guess so. Let's click. The way this is saying is you could use the color sensor CS left to check to see if the line is green, or check to see if the line is yellow. So either way, if it's green or yellow, you're going to do the same thing. So that or works. Let me just very quickly talk about that or operator. So control flow, repeat forever. I want to have, again, the control flow if this if block, if something equals something else. But instead of this in there, I actually want if this or this. So it gives me two different options. So I'm going to duplicate this block. So if color sensor is CS left is equal to green, or I'm going to put this in here now, color sensor is equal to yellow, do something. So this allows you to track two different colors, this or. So if it's green or if it's yellow, do this. And remember, you're going to want a do and an else. Because if it senses the line, do something. If it doesn't sense the line, do something else. Okay, so that I think is a pretty good heads up on everything that you need to know in order to accomplish these tasks. So go ahead, get at it, and I'll see you guys again in class on Thursday. All right. Until next time, enjoy robotics.